This is lesson 1.5. Our objectives are to review and practice solving some linear equations, and then to learn how to rewrite equations to solve for a given variable. Let's go ahead and start with a little review. Let's try these three problems. Let's practice solving. So in our first problem, we just need to remember that we have to distribute and combine like terms before we can actually solve. In this case, we have 2, which is multiplied by the b plus 3, so we need to distribute the 2 into the parentheses. When we do that, we get 2 times b, which is 2b, plus 2 times 3, which is 6, and that equals 4b minus 2. Now I'm ready to combine my like terms. I can either move the 4b over to the left or the 2b over to the right. I'm going to combine my variables first. And I think I'll move my 2b over to the right so that I don't end up with a negative. But if I did, I will still get to the same answer. 2b minus 2b gives us 0. So all I'm left with on the left side is just the 6. 4b minus 2b is 2b. And then I have my minus 2. Now I will combine my constant terms. So I will move my negative 2 over to the left side. So I will do the opposite. I will add it since it's being subtracted. And then on the left side, I am left with 6 plus 2, which is 8. And then bringing the 2b down. The negative 2 plus 2 gives us 0, so those are gone. My final step then would just be to divide. 2 is being multiplied by the b. And in order to isolate the b and solve for b, I would need to do the opposite, which is division. In this case, 8 divided by 2, I'm left with 4. 2 divided by 2 just turns into 1, which is what we want. So we're left with 1b, which is just b. And that is our final answer for example number 1. Let's try example number 2. In this case, I have 4 equals 2/5 times g. So a trick that we can use, because we need to get rid of this 2/5, and it's being multiplied by the g. So what we can do is multiply the 2/5 by its reciprocal. Its reciprocal is 5/2. And if we take 5/2 times 2/5, think about what we get. 2 times 5 is 10. 5 times 2 is 10, so 2/5 times 5/2 gives us 10 over 10, which is just 1, which is what we're looking for. The one thing to keep in mind then is that if you multiply the right side by 5/2, you also will need to multiply the left side by 5/2 as well. Okay, so let's go ahead and perform that operation. 4, if it's by itself, remember that it is over 1. And sometimes it's easier to write that it's over 1 so that you can line up your multiplication. 5 times 4 is just 20, and 2 times 1 is 2. And then on the right side, all we're left with is g. Because remember that 2/5 times 5/2 cancels, turns into 1, which is just 1g. So to finish this problem off, we would just want to reduce 20 divided by 2, is 10. And that is what our g equals. So our final answer is 10. G equals 10. Last problem. In this problem, we have 3 plus 8/7 times d equals -1. First thing we want to do is always move any addition or subtraction to one side. So we will combine our constant terms. I'm going to subtract the 3 since we have a positive 3 here. When we do that, 3 minus 3 cancels, it becomes 0. And all we're left with on this side is 8 over 7 times d. And on the right side, -1 plus a -3 gives us -4. And now we can use the trick that we used from example 2. We can just multiply by the reciprocal. The reciprocal of 8 over 7 is just the reverse of that. We flip it, so we get 7 over 8. And if we multiply the left side by that, we need to multiply the right side by 7 over 8 as well. And we know that 7 over 8 times 8 over 7 is just going to become 1. 7 times 8 is 56. 8 times 7 is 56. Any number divided by itself is always 1. On the left side, then all we are left with is D. And on the right side, again, if you like and it's more comfortable, draw a line and put 4 over 1 so that you can multiply straight across. Negative 4 times 7 is negative 28. 8 times 1 is 8. Now we can't simplify this in the idea that 8 does not go into 28, but we can actually reduce this. So let's think about what goes into 28 and 8. And 4 goes into negative 28. 4 also goes into 8. 4 goes into 28. Let's see, 7 times. Do a quick mental division. 4 goes into 8 2 times. And our final answer is going to be D equals negative 7 halves. All right, that concludes our review. Now let's look at how to rewrite problems. We have a few examples. In this example, you are given an equation to calculate Celsius. This equation will take a temperature in Fahrenheit and turn it into Celsius. But what happens if somebody tells you the Celsius temperature and they want to know what the Fahrenheit equivalent of that is? You wouldn't know. And so if you can rewrite this equation in terms of C, in other words, you're going to put C in the equation and you're going to put F outside of the equation, then you'll have a nice easy equation to figure that out. So let's do that. The first thing here is to get rid of our 5/9. Either that or we can distribute it, but I think I'd rather just get rid of it, and that way the parentheses can fall off. So in order to move that to the other side or get rid of it, we would multiply by the reciprocal. We just flip it. So we multiply 5/9 by 9/5, which means we would also need to multiply C by 9/5 as well. On the left side, 9/5 times 5/9 becomes 1. And if you think about that, 9 times 5 is 45, 5 times 9 is 45, and any number divided by itself is always 1. That means now our parentheses can go away because we have nothing to distribute inside the parentheses. I will just write F minus 32 is equal to, and I'm going to put the 9/5 in front. Doesn't matter if it's in front or in back, but I'm going to go ahead and put it in front, 9/5 C. Our final step then in order to isolate F and write our equation in terms of C is to just add 32 to both sides, and then we should be done. So our equation ends up being F equals 9/5 C plus 32. Now, if you're in a country where everything is in Celsius, you have a quick equation where you can just plug this in, multiply by 9/5, add 32, and you will have the Fahrenheit temperature. Let's do the same thing with example 5. In this example, you know what the equation is for the area of a circle. It's very common. Area is equal to pi times r squared. And in this equation, pi, as you know, is 3.14, and it actually continues on 3.14, number, forever, because it's an irrational number. We tend to think of pi as just 3.14. So in this equation, we are looking at rewriting it in terms of the area. And this is because at your work, your boss wants to know how big to make the radius of different sized pizzas given a certain area. So maybe he knows what the area is that he wants, but he doesn't know how to do that. He doesn't know what the radius should be. So he tells you that that's what he wants, and you decide that you will rewrite this equation in terms of area so that you can calculate that. First things first then. So we're going to be solving for r. And in order to do that, we have to get rid of this multiplication. So we need to divide by pi. And you would do that first rather than getting rid of this squared. When you are solving for a variable, you do PEMDAS in reverse. So you look to see if there's addition, subtraction, move those out of the way. You look to see if there's multiplication or division, and you get that out of the way. Then you look for your exponents. So if I divide that side by pi, then I would need to divide the left side by pi. On the left side, then I'll have area divided by pi. And on the right side, I will just be left with r squared. If you'll notice, pi divided by itself, any number divided by itself, cancels out. It becomes 1, and that leaves 1r squared, which is just r squared. Our final step then is now to get rid of the squared. Well, the squared just means that we have r times r. So we just want 1r over here, not 2. And the way to do that then, to undo something that's squared, is to take the square root. So if we can take the square root of r squared, we should just get r. Well, again, whatever we do to one side, we need to do to the other side. So we have to take the square root of the a divided by pi. Okay, if we take the square root of something that's squared, they both cancel out. And then on the right side, we will be left with just r, the radius. And on the right side, we will have the square root of our area divided by pi. So if your boss says, hey, I would like an area of 20 square inches, you can just plug that in the area, divide by pi, take the square root of that, and you will get the radius. All right, let's look at our last couple of examples. And these are going to be used fairly quickly by us because in these examples, we are trying to turn these into y equals mx plus b in order to make them easier to graph. In our first example, we created this equation because we bought 4 Big Macs and 8 Cokes for some price that we don't remember, but we know that we spent $16. What I want to do is graph this equation. Now I could make a table of values and I could graph it that way, but it's a lot easier to set it up as y equals mx plus b because that's slope-intercept form, meaning I know the y-intercept, I can plot that. If I know the slope, I can just do rise over run, plot another point, and it's easy for me to graph this equation. So in order to do that, I need to rewrite this in terms of x. So first thing is then to move 4x to the other side because I'm going to leave y right here so that it will be y equals mx plus b. I will then subtract 4x from this side and then subtract 4x from the right side. All I'm left with now is just my 8y. And then I'm going to go ahead and write the negative 4x first so it's more similar to the mx plus b format. I can write it first or second as long as I keep and maintain the integrity of the signs. This is a negative 4x. Notice it's still negative. This is a positive 16, and it is still positive. My final step then is to get rid of this 8, which means I need to divide this side by 8. Be careful because if I divide the left side by 8, I have to divide the entire right side by 8 as well, which means I have to divide the negative 4x by 8, and I have to divide the 16 by 8. You can't forget to divide them both. So on the left side, 8 divided by 8 is just 1, and I'll be left with just 1y or y. On the right side, negative 4 over 8, I can reduce that. Negative 4 goes into itself one time, and it goes into 8 twice. Leave the x there, and then 16 divided by 8 gives me 2. In our final example here, I'm keeping track of my calories. So last week I burned 3,500 calories. I know that I spent 10 hours swimming and 5 hours running, but I don't remember how many calories I burned per hour swimming or how many calories I burned per hour running. But I do want to go ahead and graph this equation. It says rewrite the equation so that it is in terms of x. Unfortunately, I don't have x here. So I have to decide which term I want to be x. It's not really that important to make sure that you either choose r or s. What's important is to make sure that whichever one that you choose, you understand that it represents x. Therefore, it is part of your domain. Therefore, it is part of your independent variables. It goes on the x-axis. And the other one is your y. So in this example, I think what I'll do is write it in terms of s. So that means I will make this be r equals. First thing then I'm going to do is I'm going to subtract the 10s from the left side. which means that I will then subtract the 10s from the right side. On the left side then, I will just be left with 5r because 10 minus 10 gives us 0. And I have just 5r here. I'm going to write the negative 10s first, again, so that it can be in this mx plus b form. And then I have to write the 3500 then on the end. Notice that the integrity of the signs is maintained. As this is a negative, it's still negative. This is a positive, and that's still positive. My final step would then be to divide both sides by 5 in order to isolate r. Remember, again, you need to divide both terms by the 5 in order to have your equation still be equivalent. On the left side, then, I'm left with r. And on the right side, I have negative 10 divided by 5. That gives us negative 2s plus, and then I can do 3500 divided by 5. Feel free to use a calculator if you need to, but that should get us 700. So in this equation, I've written this in terms of s representing my x, my independent variable, and r representing y, my range, or my dependent variable. So r will depend upon s in this situation. And that concludes our lesson today on rewriting and solving multi-step linear equations. We'll see you at the next lesson.